Hello folks, it's Monday and we're going to be taking Alan's radios back to his intermediary in a town nearby. So I think we're going to do a road trip because some nice countryside. It looks a nice day. We'll make sure we stop the video in good, what's the word, well short of his intermediary's address. Right, so we've got this from one of our regular customers, and it is the Binatone Long Ranger 6. So we did a Binatone Long Ranger 40 actually for this gentleman a few weeks ago. This is a rather immaculate 12 channel one. So you've got a bizarre set of channels, we'll come to that in a moment. The synthesized radios, the synthesizer used is exactly the same one as is used in the 40 channel one, exactly the same one used in the 6 channel one. So some people might think that the 6 channel one's probably crystal controlled and the 12 channel one could be crystal controlled, but they're not. They are synthesized with an obsolete synthesizer. In America, this same product was a Royce handheld. It had a signal meter. It even had PA for whatever reason. Hello, I'm using a PA on a walkie-talkie, that's good. So, this is what he says. No history on this, I bought it last week. It doesn't transmit on some channels. I fitted an antenna off an old unit, so that's fine. And it's got to be the right antenna. You can't have one which is an element less or anything, because the internal SWR would be high and then it would destroy the transmitter. So that's really immaculate. I've got a 6 channel one here just to show you. This is not a repair, this is going to be a scrap set. So here's the 6 channel one of ours. So it's exactly the same. They all do 6 miles range. We've done those range tests. It goes throughout our difficult terrain course because they've got such long telescopic aerials. And they do 2 watts plus. It's difficult to see what they really do because you end up having an adapter tree into the aerial socket, but they are sold as a 4 watt set, and unlike the German handhelds, which 4 watts meant input power and the output was actually half a watt, they are relatively good power. So they're up there with the realistic 1001s, but because they don't take an external mic, they don't have much use. So whereas you can put a realistic 1001, 1005 on the seat of a hire car with a magnetic aerial plugged in, using the extension mic and legally be using it, obviously you can't be pulling a massive aerial up. They do have aerial sockets, so you can put a mag mount on your car. It does say battery charge is 450 milliamps, and did we come to the conclusion that they draw 900 milliamps, something like that, on transmit if you power them from this socket. So they should have an 8 battery pack with them. You can use them with a 10 battery pack if you're using rechargeable batteries. It doesn't say that in the instructions, but you can. So let's have a look. Of course I haven't got anything like that. Gone are the days when we all had coins in our pockets to open things. So it's got a replaced, they were black originally, one of those, 8 times AA, but it will accept a 10. There is space. So you don't have to then mess, so you can put 8 alkalines in this. If you want to use rechargeables, you'll need the 10 pack, or you'll end up with less range because you'll have less voltage. So let's see whether ours has got a battery pack in it. I bought these off, both of these off eBay. It's one of my weak moments. Yeah, it does. So again, it's got the 8 battery pack. I thought that was a replacement. It probably is a replacement. Now sometimes you see these on eBay, and usually in the starting with a 99 pence type of arrangement, and they've got a PP3 9-volt battery clipped onto there. Is that 6F22 in American? You all know what I mean, the transistor radio battery. And they've got it switched on, and look, it's showing it working. Well, it doesn't work on a 9-volt battery, and a 9-volt transistor radio battery is going to give you 80 milliamps, isn't it, at best? Well, these sets are going to be transmitting at nearly an amp, so just like anything else. So that is sometimes you're going to get one for a song because the readily available battery pack's missing. And I stock the 8s and the 10s. I'll tell you what, there's a massive price difference between the 8s and the 10s as well. It's like £5 for the 10 and £1.50 for the 8, something like that. Now look at the back. Look at what it says on the back. So it starts on channel 6 and goes through to channel 11. So back in the day, you might think that 9's useful in an emergency. So on this one, it's going to give you 9 and 14, but it stops at 17. So there are people who might actually want to use 19 other than swearing at each other in Nottingham. So it's a bizarre set of frequencies. There you go. There was a £10 price difference. I think these were £49.99 and these were £59.99 or even £69.99. But there's no difference. How much extra does a 12-channel switch cost to a 6-channel switch? You know, what's the cost difference? 50 pence? I don't get it. But I think they saw an opportunity to probably not make a lot on this one and make a hell of a profit on this one. Anyway, they work well, and because this has had the kiss of death, it's scrapped. See, it should have the telescopic. But I thought, well, one will come in one day, and we'll have a good outer case on a set, and a telescopic aerial, and it'll be of some use, because it's otherwise in nice condition. So I'll put that down. So these are a pain to work on, and we will open it up. They're a pain to put back together, and we've got another 40-channel one of these already come in. Now we're going to do we'll do another couple of sets in between. I am working on a Macom EM27. If you remember those horrors, they worked great for about 3 years, and then you got the battery causing problems. And I have gone to a lot of trouble so far. I'm just going to digress with the Macom we're working on. It's from one of our customers who's disabled, and it hasn't had much leakage, but it has had some leakage. I've put the memory capacitor in instead. So I really want to get to the bottom of why these go howling. And so I've changed the capacitors. We've changed the audio IC just in case. Obviously we've done that. We know it's holding its memory, so we know that's connected properly. It's not so corroded, and I don't think it's actually gone through. We've disconnected the input pin to the audio IC, and the audio IC works absolutely normally when not connected to the rest of the radio. Conversely, we've connected an external bench amplifier to the input pin, and the radio works absolutely perfectly on receive. Put the two together. Wah! Is it lacking decoupling there? It's something we're going to look further into. Mr. Chip and I have had our heads together. At the time, these weren't worth bothering with. Once the battery had failed and that, they were just not worth bothering with. And at the time, the wholesaler was charging, what, 34 quid for them or something? They were dead cheap. There was a good markup, I've no doubt, but they were dead cheap, and so they weren't worth bothering with. But these days, they might actually be worth 40 quid second hand if they're working. Trouble is, a lot, because they've got a capability outside of the UK, the gas poker brigade get to them, and there you go. So, if anyone knows a real cure, and not a Reddit on Facebook cure, and it isn't the capacitors and the audio chip and the battery, if anyone knows a real cure, you could save Mr. Chip and I some time, because there is a fundamental problem that those go into self-oscillation because something happens to them when they get to be 3 years old. Now they're 23 years old. Well, we've probably got about 17 of the things. Mostly in bits. Because that's how we bought them. That batch I bought from Lancashire's got one of those in it. Right, back to the real radio. And these are capable of working. So it's exactly the same as the 40 channel set. I don't think you get the crystal filter though. They're not easy to service. So you've got, oh, it has got the crystal filter on receive. You know what? I'm surprised. So you've got to have a secondary signal generator to set the receive frequency, because if you remember, you've got the master oscillator, which is non-adjustable, which is probably 10.24, but don't take it for gospel. What does the crystal say? Oh yeah, the crystal says 10.2 something. I've only got 20 minutes on this session. We're probably about at time now. Otherwise we will never get to Alan's intermediary. Yeah, it's 10.24 as the reference oscillator, and it's non-adjustable, a bit like Unidems are. And then you've got the mixer crystal for transmit and the mixer crystal for receive. I'll have to look back on our notes. You've got crystal filter on receive, so it's half decent. And the complaint, as you saw with this, is that not all the channels work. So the channels are all in the set somewhere. It's going to be, surely, unless there's a data line out on the phase lock loop chip, it's going to be a dry joint somewhere. So we'll have a look at dry joints. I'll put about 5 pairs of glasses on. I'll even put the soldering iron on today as a special treat. I can see a not so good joint on there for a start. So these are actually the actual wires going to this subboard. So that is connected, that is connected, that is connected. The yellow one is connected. The brown one is connected. There could be some iffy soldering there, so we'll just go through those pins when the soldering iron warms up without trying it. So what did he say? Doesn't transmit on some channels. The other side to that is the VCO could be out. Now the VCO has never been messed with. I think we're going to have to test this, because if it's receiving on all channels and it isn't the phase lock loop or the channel selector switch, it's going to be the VCO that's out, and it can happen. Now we don't have a method to set these, but I do have that phase lock loop data book, and this type of chip is in there. Might just help. So I think we'll get this connected up to power, and we'll get our adapter tree. Back to that York 867, which we're taking back to Alan's intermediary. Just remember, when we get all that hum on it, the base area is only 7 feet from me here. We do standardised tests, don't we? All the sets are tested the same. So every set I do, I go high-low power to our base station on the air test. This is a hum test, and that's what we're looking for. So what I don't want to do is, there's some very kind people, so we could put a ferrite bead on here, we could put a ferrite ring on here, yeah we could, and we could put, if we look at the scrap chassis which is left behind from Alan's, you've got, on the power input, you've got no ferrite, so the power lead is going to be introducing the possibility of RFI into the power lead, so you should have ferrite beads on there, and because we've chopped the mic socket off to give him that front back, they've got no ferrite beads on there either. The other thing you need to do is, if any of these wiring has been, and we've made sure this was done of course, is you've got to make sure that all this wiring is tie wrapped in. So if you've pulled any of the wiring out, it's got to go back in the loom. You've got to make sure it's pressed down lower than the screen so that the transmitter isn't going into it. We actually took a photo. I have a photo from our 1981 original. here, and this was taken with a back in the days of 35mm cameras, and unfortunately I did it with flash, which was an error. We soon learnt about it, because back then you had to wait for your film to come back, didn't you? So it was then done on time exposures, but you can see how all the wiring is really neat on a factory original brand new set, and on this set it's all pulled about. So another thing which causes RFI. So it's ferrite beads on the microphone, ferrite beads on there, and if you still had problems, then you could put a ferrite on the power lead and you could put one on the aerial. But it's not something we're doing when we're testing sets, and those sets work fine in vehicles. Right, I've got the adapter. So we want a power lead. We have one somewhere. Power supply on 12 volts. Power on. Lovely. Right, we'll switch picture in picture on. And where are we? Let's put it to the lower one, it works better. So I'm on low power, so we'll put the test set to low power. So full scale deflection is 3 watts. The radio is doing 100 milliwatts. And it's on channel A. Well, I think it is. 68125 that should be. So if I get the back, channel A. Oh no. 68125. That's channel D. But this might be the fault. Channel A. 760. That's channel L. I can't get this off again. Oh. Right, channel A. Seven 750. That's channel K. Yeah, this is all over the place. Channel A. What I'm going to do, it's going to be easy if I just pop it on frequency. I'm not quite sure. It's 10 minutes since we last did the last one. I can't remember whether that's receive or whether that's received. So we'll start on that with transmit. I'll just put the frequency counter up so you can see what I'm up to. Not that one. Nice quality trimmers, these. So as far as transmit goes, it's gone on frequency. So I say receive is done separately with the marker oscillator. 75125. 2775125. 2775125 is channel K. So If I move it up one, is that channel L? 76125 it is. If I move it up another one, we should be back to channel 1. So it should be 65125. It's not, it's 68125, which is channel D. So we have a data line out. Here's another thing. It's received the same as transmit. When he said it was not transmitting, I just wonder if it goes on a channel which isn't authorized. So let's just have a look. Back to that, 6.8. Next channel, 6.8 is the same. Next channel, 6.7, which is C. Yeah, there's a data line out. So I'm going to once again, 6.8. I think that should be the A position. And that should therefore be the L position. 7.6. Yeah, I reckon we've got that right. So I think that should be the A position. So we've either got a data line out on the chip, or we've got a dry joint on the channel selector switch. So I'll switch the power off. Yeah, so it's got some channels that are the same. What you don't want with faults like these and general purpose synthesizers is, you know, the next thing you're on cruise missile frequency by mistake. So in case it was a dry joint on the switch, let's power it back up. We should be on channel A, and it's still wrong. Channel B is exactly the same. Channel C is down one, so we still have that anomaly. Next thing, we're going to have to take the board out. So I'll disconnect it totally. I'd rather not take these boards out. And some of them are clips and some of them aren't, so you can end up taking wrong screws out. So those top two, the best way here is to take the rod antenna off. You don't have to be touching that in transmit. You know, these are called the Long Ranger. It's one of those things which is actually true, along with those realistics. The 1001 and the 1005, not the 1007. The 1001 and the 1005, you know, we've had 14 miles out of them, and we have with these. Not on the current test route, but on a good terrain for radio test route. We went out to Gainsborough, and a place called Grindley on the Hill. We had the tester stood on top of this hill, and we drove away, and we got all the way to Epworth, the birthplace of the Methodist founder Wesley, the Wesleys, and all the way to that village. And then when my late uncle passed away, we were clearing the house and all that in Sheffield. Mr. Chippy was coming from his home at Bradford, and it was upstairs. It was one of those houses, because it got good views, your living room was upstairs. And your bedroom, you got one bedroom on that floor, and you got another bedroom on a mezzanine level, kind of halfway between downstairs and upstairs, and then you've got a garage downstairs and a cloakroom and so on. So we were kind of upstairs, and it was quite high on a hill, stone-built property, and I just put the realistic 1001 or the 1005 on the windowsill upstairs, and Mr. Chippy was coming out of, come to me, begins with a B, not Brinsworth. Anyway, it was 14 miles away, and two-way conversation, and that's in a building. And you wouldn't get that with modern sets. With the certainly rider to that, not with the aerials provided. But you need modern sets because you need the convenience of size. You know, we did that Thunderpole one; it was great. I'd have a different one on the bench until it goes flat. The current bench one is the Midland 42 multi, and I found this one actually works better than the DS version in range. So which screws now? One of these is a bracket, I'm sure. No, it's not that. So is it that? Yeah, it's that. I'll just put that one back in before whatever bracket it's. On the other hand, it looks like we're going to have to take it out. I don't know what's going on here. It is still. Perhaps it's the 40 channel one, this bracket, anyway. So, is it that board we're not supposed to unscrew? Yeah, it's those screws. But as it happens, we need to get to the back of this wiring. So this board is the microphone preamplifier and speech processor. The deviation control is there. And what they haven't done, anyone who was in manufacturing would thoughtfully have put a hole in the printed circuit board to get a trimming tool into that. But no, they haven't done that. They could also, that hole could also correspond to a hole in this. And then you could not have to take the board out and do the deviation. No, they didn't think of that. You get a 2-inch speaker, you get an electret mic. Or is it 2.5-inch speaker? It's half decent anyway. So let's see what's happened here. Let's take the gaffer tape away. Because chances are there's going to be a wire off. 2, 3, 4, 5, but there isn't. So have we got a data line down? That's when you've got. I'll explain that better if I have to get the phase lock loop data book out. Right, we'll just run through the soldering of this. I'm going to do all the pins, even though that's not really necessary. So I'm sure you can see how I was thinking that when the customer told me what the fault was, I'm thinking, well, it's going to be the VCO on transmit, but it isn't, is it? I've introduced a short circuit there, or there already was a short circuit there. There's no proof, you know, that this ever worked properly when new. We only check spot frequencies, don't we? Right, we're going to power it up like this. And then I will carry on with this on the next session. Power on. Transmit. 2765125. Where's my lid? 2655125. I fixed it. Wasn't doing channel A before. So there you go, it was dry joint on that wiring on the back. So I'll see you on the next session, and we'll, while it's in bits, we'll get that deviation checked. You know what? I'm going to check that right now, and then at least I can adjust it, because I need to be just checking it with the other test set. We'll check it with this one first. Hollow. Says it's 2.5 on that test set. There's one thing, it's not going to have been played with, because nobody's going to go to the golden screwdriver expert. He's not going to go to all the trouble of getting down to that lower board to mess with the deviation, and the way that's working on the Marconi test set is spot on. But I need a second opinion, because sometimes that machine lies on this test, so we'll just do it again. How can I do this and see the meter at the same time? Wallow. 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 It will peak at 3 if you want it to, but I'm not going to adjust it. I mean, I did bellow into that. I say nobody would go to the trouble of messing with that board, and it's not been. That's not been altered to like, let's put it to full and get 1,000,000 watts out of it. And you can see the switch bank. I said about the Royce version in America. You know, there were switches for other features on other models. If you look at pre-production advertising literature. There was a meter on the pre-production one. Right, I'll see you later. At least we've... Right, so we come back on this for a moment. What I've done is to dig out the phase lock loop data book. And has it got an ISBN number? No. Anyway, what's the phase lock loop chip in these things? MS. It's OKI semiconductor, isn't it? MS 5807. Here we are. So as far as America goes, this chip's in these models: Aileron B4900, Krakow KCB4000, Palomar 49, Realistic TRC 205, and Tenor 10901, 10902, and 11302. And it says, a very old obsolete chip. Programming is binary with internal pull-down resistors to the pins. So we do know that if we ever had to work out a method to do phase lock loop, a VCO lock, that we've got a lock detector which is logic 1 for unlocked. I'll start again. Is unlocked logic 0 and unlocked is logic 1. So there we go, that's what the chip is. Sometimes there's a bit more data, MSM 5807. So anyway, we do have more data if we needed it, so that's why I was going to dig the book out just in case. But I didn't need it because it just turned out to be a dry joint. So making sure the power's off, I'll just disconnect it and we'll put some of this back together. First of all, put that gaffer tape back. And it's the machine screws. What machine screws? No, it's not machine screws. It must be the smaller self-tappers. Good. So I'll put some screws back just for safety because I don't want to have the radio shorting itself out or anything, of course. I think we'll do the one which goes to the output transistor heat sink. These use the Mitsubishi 2166, so they're very capable. And when asked to do this kind of power, are well on top of the job, which means that they can probably be a bit more, a bit less damaged with the high SWR because of the telescopic aerial shenanigans which you can end up with. Have I gone and locked the? I've gone and locked the battery terminal underneath the set. There you go. That's what happens. Right, we'll get it connected back up. And we'll actually start taking some notes of what it's doing, it's up to. So we're going to, I can't really be concentrating on anything but center channel. So we'll tune it up on center channel. I'm not going to be going backwards and forwards. So center channel is going to be 2770125. So we'll do everything on there. Oh, what channel number is that? 1, 2, 3, 4, 5, 6. 6. So if we're currently on 1, just borrow the knob back for a moment. 2, 3, 4, 5, 6. That should be where we are. Actually, I may as well put these back on. Shouldn't have to take this off again. So you remember your electret is that tiny little dot there. A lot of radios will say mic, so you've got an idea where you're pointing your voice. Because you'd think from this you're talking into the speaker, like some do use a speaker as a microphone, and you don't with this. It's electret. It isn't obvious. So we'll go back to low power, and we're on 12.8 volts. I'll check the voltage range from the instruction book in a bit, unless it says on the back. It just says 12 volts. So here goes. Switch back on. Transmit. So it's 1 point. What range are we on? 1.2. So it's going to be channel 11. I think we decided. And I'll put that into the signal generator right now. 2770125. There we go. So, on transmit, back to the main meter, let's go to high power. It's doing 1.5 watts. Deviation is 2.5, and it was about 2.2 to 2.6. You could make it do 2.8 if you really tried, but that's fine. So have we put this on frequency? I think we did, but the tester gear wasn't fully warmed up, so we'll now redo that. I think it was 075 actually, 20.7075 I think is where it was. So what we now need to do is get some receive on it. I'm plugged into the test equipment, and one day I'll unattenuate that attenuated speaker we have. So with an S9 signal on the signal generator, let's look at that on the oscilloscope. Which is there. Don't know why I'm showing you that, because we're going to see what it's doing at the moment. We'll go to the oscilloscope in a bit. So turn down the attenuator on the test set. To be honest, it's jolly good. The 12 dB synad, it is, good grief, 0.38. And this is better than the realistics, you know. 0.3 for 20. It even does 20. Many mobiles don't. 0.95. Squelch is going to be pretty wishy-washy because it's a handheld. Full squelch is 0.8 microvolts. And squelch threshold is 0.7 microvolts. Really a lot of variation there. Not. So we'll see if we get a bit more out of this transmitter. And I've not put the soldering iron on to melt the wax. So, not applicable, not applicable, not applicable, they're okay, they're okay, they're okay, not applicable, that and that work. So that got down the tick off list, didn't it? Just turn the squelch down, it's on the edge there. Right, so I've moved the attenuator, so we've got about 4 dB. I've suddenly switched. We're not doing that. We're doing the transmitter. Come on, Mr. Tango. We're doing the transmitter. We're on full power, and we'll go up the transmitter strip. Usually get to 2 watts, don't we? .6. Oh, by the way, the current consumption at the moment is 417 milliamps. I'll put that in the wrong box, didn't I? 417 milliamps. No change there. You're always going to get better range on metal cased handhelds because your body becomes part of the aerial. You're acting as a ground plane. You're not going to get that with a plastic one. Still at 1.6, no change. .7 watts. Wonder why that one was so far out. So we've got 2.7. And just for the record, we'll just see what it is doing on the other channels when we're not making it go off. So channel L, 2.7 watts. And that brings us to channel 17. And channel 6 is our first one. .7 watts. So that's nice throughout. So although we're not showing 4 watts, we've got this adapter tree. I've said before, if we did a lead which was N-type to a gold-plated RCA connector, we'd have a bit of a fighting chance. But unless you start unsoldering the aerial matching coil, some of the RF energy's in there, you know, so it's not like it's coming straight from the transmitter to the aerial socket. It isn't, and you're never going to get a true reading. But that's jolly good. It's usually less than that. I think you've seen the other ones. Right. Let's look at what's happening now on low power. It's now 150 milliwatts. It's non-adjustable. Am I correct in assuming there's no adjustments? I don't think there are. No, none at all. Other than the one on the speech processor board underneath. So our current consumption now is 529 milliamps. So to go from 1.5 watts at 470 milliamps to 2.7 watts, we're only a bit away from double the power for what? Another 80 milliamps or something? The efficiency is being brought up by doing a retune. Yeah, we all know it's never been fiddled with. There you go. Great. So the receive is the complicated bit, isn't it? Because we need to use a second signal generator. So we need to go back to the channel we're supposed to be on, which was F. There we go. Let's put just for this part of it, we'll put a normal. Well, we'll just use its own speaker. Put a good signal on, turn the tone off, bring up the second signal generator. So we can do it at 455 kilohertz, or we can do it at 10.695. It's usually easiest to hear at 10.695. Where's my crocodile clip lead gone? Somebody asked me the model number of this the other day, and I've now moved the lead and misplaced it. So on the yellow channel it's 10.695. Let's put lots of volume on. I think it's spot on channel. Yep, it is. Can you hear that? That would be off frequency. Just see where we are with the signal generator. Yeah, we're spot on. So I've now got 2770125 on the signal generator, spot on. If we go the other way, again we'll go off frequency. There we go. We're on frequency. So now we can put the tone back on the signal generator. And we'll plug in the test gear once again. Show you this oscilloscope. I mean, that was so good. I don't think we're going to gain anything because it really does work well. There's the detector. So maximum recovered audio. It was already spot on. So we'll now go to the synod meter and we'll adjust the attenuator so we're about. I've actually had to change scales. So we're showing about 4 dB. No change. There was a really micro change there. There you go. No, there'll be no difference. Crystal filters, as I've said before, this is an underappreciated set. They work really well. Got the range. You don't need 40 channels, because most of activities with walkie-talkies, you're out with friends, aren't you? And these sets can be had for a lot less money than a 40 channel set, and they work so well. Right, let's get a new reading, which won't be any different than an old reading. So for 12 dB, it's probably be worse because I've adjusted it. We've now got 0.37. Oh, whoopee-doo. For 10 dB, 0.29. For 20 dB, it's now 1. You see, you've altered it. That's how it is. Squelch will just be as lousy. Let's have a look how lousy it is. It's 0. It's actually 0.6 for full squelch. Let's find threshold. I'll unplug this so you can hear it. It's 0.22. So it has altered it. But you're not buying these to use as a base station, so you've got that oversensitive squelch for what would be if you were using it in any other way than a handheld. Right, so we'll start putting some of this together, and we'll need to do a test with the aerial, because it's had the aerial swapped. We need to just make sure that if I presume he took one off a scrap similar set. So we'll now extend the aerial fully, unplug the external aerial, and now we'll see if we can set the field strength. Battery pack snapped through there. That in its guide rails, whilst holding on to it. So I've got my thumb on there, holding this downwards, the case downwards, we have lost the plastic grommet. The plastic grommet is absolutely vital. So the plastic grommet is in there. So having recovered that, we'll start again. Holding that into position, it's in its guide rails. You've got to slot the case around the plug and socket panel. Whilst getting it the right side of all the clips. Just not quite in the guide rail at this side. Now it is. Oh, I did that inside 2 minutes. tell you what, I'll give the customer a 10 out of 10 for putting this back together successfully. Right, there we go, we're all done. So we'll plug it back into, this time we'll plug it into the roof area. I'll take the test equipment off. Power back on. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 1 for Roger, 15, 16, 17. Go through them again. Bit of something there, wasn't there? Right, we'll just check with our handheld. So we're on channel, I'll do the squelch on this. So we're on channel 6. Got to ascertain that all the channels are now where they should be. This wants to be on low power if it isn't already. That'll be it. There we are. Testing 1, 2. Up to channel 7. Testing 1, 2. Channel 8. Testing 1, 2. Channel 9. Testing 1, 2. Channel 10. Testing 1, 2. Channel 11. Testing 1, 2. Channel 12. Testing 1, 2. Channel 13. Wrong way. Testing 1, 2. Channel 14. 1, 2. Channel 15. 1, 2. Channel 16, channel 17. Oh, I didn't get bleed over. So there we go. We'll do an on-the-air test later from the bench, and I'm sure that will work absolutely fine. Thanks for watching. Binatone Long Ranger 12. Hope you've learnt something.